Here's the video with the solutions for functions and linear models. The first problem is about, you don't need the calculator for this one. Basically what you're doing is you're looking at each one of these lines and you're trying to figure out which line equation corresponds to it. And even though there's no numbers written here, you can figure it out just by what you know about gradient intercept form. So if you remember, gradient intercept form is looks like this. Um, y equals mx plus c. And remember that m is the slope and c is the y-intercept. So we use this form to figure out which one of these equations corresponds to which diagram. So when you have y equals c, that basically says that the slope is 0. And so if the slope is 0, then it corresponds to this one. When the slope is 0, it's flat. So this one, number 2, corresponds to y equals c. Okay? And then when you look at slopes, you know when you calculate the slope, even if you don't have exact numbers, you can look at this triangle and you can see, okay, the rise here is actually going down. It's -1, and the run is like +1. So what would be the rise over the run? It would be -1 divided by +1. So the answer is -1. And I just estimated here 1 and -1. I can't really see exactly how much it is, but so the slope would be -1. And then if I went down here, are there any of these equations with the slope of -1? Oh, yes, there is. This one here, that has a slope of -1, so that corresponds to diagram number 3, right? And then the only tricky one is the bottom one, because it basically has two equations that are very similar. It's got a slope of 3, and it's got a slope of 1/3. Well, if you think back to rise over run, how would you draw a slope of 1/3? Well, it would be rise 1 over run 3, and what would that would be 1/3. So this would be a slope of 1/3. How would you draw a slope of 3? Well, 3 would be 3 over 1, so it would be, oops, that was not a good drawing. It would be 3 tall, rise would be 3, and then the run would be 1, so it would look more steep. And so if you look here, you can see that the steep one going up positive would be this one, and then the one that's not so steep would be this one. Okay, and we know it's these two, one of these two, because these are positive slopes. They rise as we go to the right, and this is a negative slope because it goes down as we go to the right. And I just put these notation here. I put g negative, g positive, because I'm just saying the gradient is positive, the gradient is negative, and the gradient is 0. Okay, so that's all you do for that one. Number 2, it's asking you to make a mapping diagram like we did on the first problem set worksheet. And so basically we got the input here on the left and we got the output here on the right. The equation we're going to use is this one here, 3x minus 5. So we just take 1 and we put it into 3x minus 5, and that's just 3 times 1 minus 5. 3 times 1 minus 5 is equal to -2. So p would be -2. Right? P is unknown here. And then they ask you, okay, what number would give you 7? So what number would you put in here to get 7? And you can use algebra to do this, or you could put it in your calculator. It's like you could graph all this on your calculator by, let's see, you could go, so you go to y equals, and then I would put in the equation 3x minus 5. 3x minus, oops, didn't work. 3x minus 5. Graph it. Okay, and then I would just look at this in the table maybe. So I'd look at it in the table, and then I would see values for this, and then when it asked me, okay, when would it be 7? Well, it would be 7 when x equals 4. So you could do it without algebra by using your calculator. But if you wanted to use algebra, you of course would just take 3x minus 5, and then you would subtract or add 5 to both sides, and then you would get 3x by itself. 3x equals 12, right? And then if 3x equals 12, you know that dividing both sides by 3, you would get 4 for x. So 4 would give you 7 in this case. And 5 or 10, you don't need to calculate anything for that. So the answers are p is negative 2 and q is 4. Let's go on to the next one. Okay, so part B. There's a function g that looks like this. 3 on top, x minus 2 squared on the bottom. So it says, what is the domain for the function? Well, you always start by thinking, okay, the domain is any real number. Okay, is that true? Well, almost true. You can put any negative number in here. You can put any positive number in here. You can put 0 in there. The only number that you can't really put in there is a number that's going to make the denominator go 0, because that is invalid. Okay, if you have a 0 on the bottom, it turns into infinity, and in this class we just say we don't want the domain to be 0. So we put x equals 2, and then that would make the bottom into 0. So we know that x equals 2 is not allowed, so we put, yes, x is a real number, but x is not equal to 2. And then what about the range? What is the range for this function? Well, this function can be a lot of different numbers, but you can see that the bottom is always going to be a positive number, right? It's squared, so it's always positive. And so 3 over any positive number is going to be any positive number, pretty much, right? So we're going to say any positive real number as a result. There's one number that you cannot put in the bottom, and again, that would be 0. So so we know that, or I'm sorry, no matter how big you make the bottom, you can never make it into, you can never make g into 0, because, like, let's say you make the bottom into 10 billion. If you put 10 billion here. Even if you put 10 billion here, this would still be a really, really small number, but it wouldn't be 0, right? So even if you increase this to a Google, it still wouldn't be 0. So you can't put any number in this expression and make it 0. So this expression will never be 0, although it is always going to be a positive real number. So it's a positive real number, not 0, so we would just say it's g of x is greater than 0. Okay. 3. Now this is a review of the first couple weeks of our class back in August. So remember, natural numbers, integers, rational numbers, and real numbers. Real numbers we've been talking about recently, so that's fresh in mind. Natural numbers, remember, natural numbers are what you learned in preschool. So 1, 2, 3, 4, 5, okay, plus 0. Okay, so any number, any whole number starting with 0, natural number. What about z, which is the integers? That's kind of hard to remember. An integer, I know a lot of you are forgetting what integers are, but integers are just whole numbers, but they include negative whole numbers. So what's the difference between natural numbers and z real integers? Well, integers include negative whole numbers, and natural numbers are only positive whole numbers and 0. Q, what's that? Q, just remember, Q is quotient. Quotient is a division. So Q is any number that can be expressed as a division of two whole numbers, which is a rational number. Okay, so that's the hardest one to remember, maybe. That Q is rational numbers. So the only things that aren't rational numbers in our class are numbers like pi and square roots of numbers that aren't perfect squares. So if we look here, 2 is a natural number, it's an integer, it's a rational number, it's a real number. That's an easy one. Square root of 3, it's obviously not a natural number or an integer. It is not a rational number either. Rational numbers do not include square roots or pi, square roots of numbers that are not perfect squares. So it would include square root of 4, but it doesn't include square root of 3. And of course, it's a real number. Okay, the only thing that's not a real number is like square root of -1, which we don't talk about in this class. And negative 2/3. Negative 2/3 is not an integer or whole number, so it's not a natural number. It's not an integer. Q is, remember, rational numbers. Negative 2/3 is a rational number. It's a division of two whole numbers, so that's fine. And of course, it's a real number. So we've mapped that out. We've done a little review of last August. Okay, now B. A function f is given by 2x squared minus 3x, and x, the domain of x is negative 2, 2, and 3. Draw a mapping diagram, okay, and write down the range of function f, okay. So the mapping diagram is this, negative 2, 2, and 3. What does it map to? Well, negative 2 maps to 14, 2 maps to 2, and 3 maps to 9. And you could just put this in your calculator. Let's do the first one because it's probably the most difficult. So we'll put 2, we'll put 2 times negative 2 squared, which we do with this, and then we just do the arrow to go back down to the plus, and then we're going to add it to minus 3 times negative 2. So we're going to do minus 3 times negative 2, and the result is 14. Okay, so that's correct. Alright, so you can just do those all in your calculator. Write down the range of function f. Well, let's look at this. What would come out would be, any real number, except you can see there's a squared here, right? So since there's a squared there, no matter if you put a big negative number in there, it's gonna end up being positive. The 2x squared is always gonna be a big positive number. So there's certain negative numbers you might be able to get, but at a certain point you won't be able to get negative numbers. And to give you an example, if you put 1 in there, well, I'm sorry, forget what I said. In this case, the domain is negative 2 and 3. So the range here is only 14, 2, and 9. So the range is 14, 2, 9. I thought they were asking something much more complicated. Forget what I said. So the range would be 14, 2, 9. And then we're done. Okay, number 4. So these functions we're just going to analyze. We go to the question here. It says each of the following sets represents the range of one of the functions of the graph, and just tell me which one of the graphs corresponds to this range. For example, the first one's an easy one. It just says all real numbers. Do any of these correspond to all real numbers? Well, you can tell that most of these do not range from negative infinity to infinity. The only one that ranges from negative infinity to infinity is this one. So that would be number 3, right? It ranges from negative infinity, it goes on forever, to positive infinity. So that would be real numbers. That's the first one. Second one, anything greater than greater than 2. What's greater than 2? Well, not that one, not that one. Oops. Looks like this one, right? So this is always greater than 2. And that would be 1. Okay? And then what about this one? Y is always positive. Is there anything always positive? Positive. This one. Okay? It goes to infinity too. Y is positive. Okay? So that's that one. And the last one is y is between 1 and 2. Y is between 1 and 2. So it should be one of these two that's remaining. Now this one you can see it goes from, I did something wrong here. Ignore that. This should be 0 to 2, right? The bottom value is 0 and the top value is 2. This one here ranges from 1 to 2, right? So actually the answer would be 4. Okay? And I am going to continue this in the next video.